Hello, my name is Aubrey Moore, and I'm a consultant with Reveal Group. Reveal Group is a leader in intelligent automation services. One challenge we see a lot of is processes being disqualified for automation because they were triggered by an email or some other free-form text. There are tools and techniques we can use to apply structure to those unstructured communications to keep those processes suitable for automation. One of those tools is Reinfer, a communications data intelligence platform. And I'm here with Joe Prosser, Reinfer's automation architect, to discuss NLP and some of the pitfalls you'll want to avoid when implementing NLP in your organization. So Joe, I've heard you say that the world isn't a classification problem. Can you explain a little bit more what you mean by that?
Yeah, sure. Thanks, Aubrey. One of the things we can do with NLP is kind of summarize the intent of the user. So, when we've got a piece of text, that piece of text is going to be asking us something or telling us something, and we kind of need to figure out what that is. So, you can imagine in a sales setting, you might have like a new order, an order amendment, maybe a complaint, maybe a chaser, just kind of different processes and kind of request types that are coming into a mailbox. And there's kind of two ways the current kind of NLP tooling goes about solving this problem. So the first is classification, where we look to bucket requests into single kind of classes, right? So we if we have a new order email, that will go in the new order class. If we have an amendment email, that will go into the amendment class, and that works well in a kind of academic setting. However, we find it in the real world, people are going to ask you multiple things in a single email. So you might have an email that says, hey, can I make a new order and change my last two orders? So that's a new order and an amendment. Yeah, the kind of approach that we take at Reinfer is a kind of multi-tagging, multi-classification, and hierarchical approach to labeling as well. So we don't look to bucket emails into a single class. We look to surface everything that a particular communication is asking you. So you can get a really kind of granular understanding of exactly what that request is asking. And it means that we can automate more, right? So we can automate multiple requests based on a single email. And yeah, that's kind of the approach we take. And we believe that's the right approach if you want to automate at scale.
Very cool. And I hear a lot about, NLP and sentiment. And so, can you maybe give an example of where sentiment sort of plays into this, the multi-label or that kind of approach? So, yeah.
Yeah, sure, and that's a really key point, right? So we don't just have to look to kind of extract processes or request types. We can try and kind of detect more abstract concepts in the data as well. So sentiment's a great example of that, where people might be angry or upset or positive or negative about different things, and our models, we train them to recognize sentiment along with the concepts. So if someone said, "I really liked your website, but the delivery driver was rude to me," for example, that's good feedback about the website, but negative feedback about the driver. And yeah, we can detect the sentiment and attribute it back to the different kind of requests and different kind of topics within that data. So again, from an analytics standpoint, you can get a really kind of good understanding of where you're doing well and where customers think you could do a little bit better. But then from an automation standpoint as well, you can kind of tailor your responses to the customer based on how they're feeling and what they're telling you. So you can maybe be more apologetic about the driver in that situation.
Right. And I think organizations are realizing that know your customer is something that everyone has to play a part in, and being able to have those multiple sentiments tracked is really useful for that. So kind of going towards actually building your model and the labeling process. So Joe, when it comes to building your training data set for your ML model, can you explain the difference between active labeling versus traditional annotation approaches?
Yeah, sure. So kind of the biggest flaw with the traditional approach of machine learning is it requires structured annotated data upfront, right? And that's not just a problem in NLP, that's a problem in machine learning in general. So that's kind of the hard problem to solve, is getting annotated data. So you can buy tools and you can buy compute power, but you can't buy training data that really encodes your SME's knowledge and kind of knows your own business domain, for example. So active learning kind of looks to solve that problem. So instead of kind of starting with annotated data, we just start with unannotated raw data, and we'll upload that into an active learning platform. So, for example, Reinfer, and the AI will kind of help you along the way as you're annotating the data. So, for example, it will look for clusters of similar communications and then present them to you and say, I think all of these emails are about the same thing. Can you tell me what that thing is? And also, it will make predictions based on what it already knows and say, oh, I think this is a change of address. Am I right there? And then you'll approve or reject the predictions as they come through. And that kind of automates sifting through all of that unstructured data you've got, and lets us really quickly build up a massive training set for our models to train on, to validate on, and ultimately for us to automate on the back of.
Yeah, it's not hard to imagine how bias might be introduced in maybe a traditional annotation approach where you just have a dump of all of your organization's communications, and in order to identify a group, you might be using Control F, and so you're just looking for keywords to identify certain communications, and so easy to introduce bias because one person can't express all the semantic variation and just one concept or one idea. So the clustering definitely helps navigate around that sort of very human problem. So kind of getting towards validating your model. So we've got our training data, we've annotated, and now we're trying to deploy to production. So how do you ensure that your model is performing?
Yeah, sure. So you could use the standard kind of metrics-based approach that all machine learning models use. So mean average position, F1 scores, basically counting how many predictions you got right versus how many you got wrong, and then combining the two. But then also what you said there about bias is really interesting as well, because it's really easy to create a model that appears to have really good metrics, but is actually trained on biased training data. So when you use a active learning approach such as reinfers, we can kind of take into account all sorts of different things as well. So we don't just look at the predictions; we also look at, oh, let's compare the training data we've got to the entire data set that we've got that's unlabeled, and see how similar that is. Because you can imagine if your training data isn't similar to the rest of your data, then there might be something a little bit wrong in the model. And we can also look at how many kind of informative predictions we're making across the entire data set to get a sense of, out of all of the kind of data we've got, how much of it do we recognize? And yeah, we can use those approaches as well to make recommendations to you. So the model can basically tell you, oh, this particular concept, let's say it's an order amendment, has got this and this wrong with it. So to fix that, maybe add some more training data by going into shuffle or reviewing the predictions, or oh, we think you've annotated some of these verbatims incorrect, so can you go ahead and check those? So yeah, the validation we use is a combination of the standard, which critically we put a lot of effort into evaluating your training data and ensuring that the training data is as best as it can be, because that's ultimately what's going to affect the performance of your model in the long run.
Yes, a very good point about garbage in, garbage out. You have to make sure that that training data is up to snuff, and so we actually go into more detail with a two-page paper that you'll find attached to this talk. So title being accuracy doesn't matter. Accuracy just being one of the many metrics that you can measure your ML model against. So now we can take an opportunity to actually run through a real life example of applying NLP to an RPA process. So I'll share my screen now and we'll just walk through a quick demonstration. All right. Okay, so this is a demonstration inspired by the frustration of having to deal with airline customer service after a flight has been delayed or canceled, any of those inconveniences. So actually coming back from Thanksgiving recently, I was in the line for security, and there was a code blue, which meant that everybody stopped and they had to do some investigation. So everything turned out fine, but that was quite a long delay, and many people missed their flights, including me. So as I'm sure you're aware, Joe, in the EU, there is a regulation where if your flight is delayed, then you are entitled to compensation, something that I wish was present here in the US. But we've taken that regulation, and so we've automated a use case around that. So I may kind of breeze forward because this just illustrates what I was just talking about. All right, so in this process map, we have a passenger who has sent a complaint about their flight being delayed to a customer service inbox. And traditionally, that complaint would be serviced by a human. Somebody would have to read it, figure out what it's about, extract the relevant information out of it, and then issue a delay compensation if they're eligible. So what we have done is used reinfer to figure out that that email is about a delay compensation, to extract the relevant pieces of information out of that email, things like which airport I was flying from, flying to, the booking reference number, and my date of travel, all things necessary for the automation. And so we use reinfer to pull those things out. We're going to use Power Automate to fetch the information that reinfer has annotated and put it into a SharePoint list. And that list just serves as a queue to issue those delay compensations. And so step 5 here, we're not actually going to be issuing any reimbursement. We are simply going to send the confirmation email that it has been issued. And what you'll see in that confirmation email is some of those pieces of those individual data points that we've extracted out of the original request email. And so the cool thing about this is that that original email was just written in free form text. It could have been in any, expressed in a variety of different ways, but reinfer has been trained to identify those airports, that booking reference number, the date of travel, and also that the entire email is just about a delay compensation. So we'll move forward to where I'm actually authoring the original request email. So my flight from London to Nashville on October 12th was delayed several hours and I missed my connection. My booking reference number is RG1234. So you can see reinfer is going to look for these particular entities to extract later on in the platform. So I'm going to send this to our customer service inbox, and then Power Automate is going to detect that new email and immediately send API request to reinfer to load that into the platform. So this is the reinfer platform, and I'm going to search for that booking reference number in order to find the email. Takes just a moment, so a quick refresh, and here's my email. So I'll play till we have a few of these entities being highlighted on the screen. And Joe, maybe you can go into a little more detail as to what we're looking at here. So, I see refund, delay compensation, I see a few of these entities being highlighted. So can you just go into a little more detail about what we're looking at?
Yeah, sure. So this is that email that Aubrey just sent in the reinfer platform. So the first thing you can see there is where it says refund delay compensation. That's the label that we predicted. So that's the piece of information that summarizes the email as a whole and kind of lets us know which robot we should kick off, right? So you can imagine we're going to send this email to the delay compensation robot. And then you can see the different spans of text that are highlighted there. So you can see London, Nashville, the dates, and then the booking reference number. They're what we call entities, and these are often inputs to the automation process. And a kind of few cool things to note here is even though London and Nashville are both airports, Reinfer has been able to recognize that one's a departing airport and one's a destination airport. So we can kind of understand the roles of entities, not just the types of entities as well. And then also you can see highlighted there the travel date on October 12th is resolved back to a machine readable format. So that's going to be in a format that's really easy for automation to read. And the same goes for if you didn't type a date at all. So for example, if you said today or tomorrow or on Christmas Day, those spans of text will be resolved back to the specific dates. So it's really quick for automation to kick in and leverage that information.
And another thing that I'll just quickly mention is that I have a humongous signature attached to all of my emails, and that has a lot of text in it. And Reinfer has actually detected that that is a signature and just stripped out all of that noise that could potentially confuse the model. So yeah, after you see respectfully here, there would be a lot of my contacts, phone numbers, please reach out, things that other ML models may not be able to detect. So now that Reinfer has ingested this email, predicted that it is a delay compensation item, and pulled out all of those entities, we'll now go into Power Automate and trigger a process to pull that email back out. And this is just manual for demonstration purposes, so we have time to talk about the steps in between. But that email is going to be sent to a SharePoint list, and that serves as a queue to run the delay compensation sort of process out of. And so what we have here is the list being populated. And so you can see that what started off as an unstructured communication has now had structure applied to it. So we have the booking reference number, travel date, departing airport, destination airport, all parsed out in these different columns. And so what used to be something that only a human could delineate between, we've trained a ML model to be able to tell what those different entities are, to tell that the overall email is about delay compensation. And now we can completely automate this process of issuing a delay compensation. So Power Automate, as soon as this list item is created, there's an automatic trigger just to create the confirmation email. And so we'll see that appear in just a moment. And here it is. So your flight from London to Nashville on October 12th qualifies for delay compensation in accordance with EU regulations, thank goodness. And so you can see that we've reformatted those entities to create a custom message to the requester. So just really sort of illustrates the power in applying structure to that previously unstructured communication. And that's the conclusion of this demo. So I'll stop sharing now. And, one more thing I'd like to mention is that, we have a Reinfer demo attached to the white paper. So if you want to play around with the tool, see what sort of demos you can make yourself, please check that out. It is a very cool tool. And additionally, we also have a two-pager about the metrics that you'll use to evaluate your ML model. And so the title of that paper is Accuracy Doesn't Matter, and it is very fun. I had a good time learning about these ML concepts at the same time. It's got a little bit of a humorous twist to it. So thank you, Joe, for sharing your knowledge today, and I look forward to our next talk.